Hello Year 11 and welcome to our third video here for coordinate geometry. Today we're looking at equations of lines, and I don't think there's anything much in here that's very new, but there will be some, and it's certainly worth the reminder. So let's have a look. We are talking about a line in terms of x and y, a linear relationship between x and y. Horizontal and vertical lines are sort of special, and let's get them out of the road first. Horizontal lines have a constant value of y, so like y equals 2, y equals 7, y equals -5. Okay, that's a horizontal line, right? We could say x has a coefficient of 0. It has no x's in it, it's all y. Okay. It is a function, right? It will pass the vertical line test. It has a gradient of 0, right? A horizontal line. Now, a vertical line, vertical lines are sort of complicated. That is x equals something, right? X equals something and not a function. We won't deal with them terribly frequently, but occasionally. So, moving on, I hope. Here we go. Vertical line, x equals some constant like x equals -6. Now, here's an example. What is the gradient and y-intercept of this? Well, if I express this in gradient-intercept form, that's y equals mx plus b, I'll be able to read off the gradient and the y-intercept. And that's what we're going to aim for at the moment. So, first of all, I'm going to separate the x's and the y's. You can see that here. Right, we subtracted 3x and 6 from both sides. Then what I'm going to do is divide both sides by -2. Right, and some of those negatives cancel out. Be careful there. In fact, that's us in gradient-intercept form. So we can see the gradient is 3/2, or 1.5, and the y-intercept is 3. I could check this. How could I check that? Well, we could try punching that into Desmos, and here we go. There's our original function here. Let me get my head out of the road. And can we see here that we have a gradient of 3/2, or 1.5. Notice we go across 1 square, up 1.5 square. Cross 1, up 1.5. 1, 1.5. Okay, that's a gradient of 1.5. It's going up 1.5 squares every time I go across to the right 1 square. And my y-intercept, we calculated it should be 5. Oh, sorry, it should be 3. And there it is, there at 3. Okay. So Desmos, who would have thought it'd be handy? Of course it's handy. It's a lovely way to check your work when we're doing these sorts of things. Now, we've got another example. What about the equation of the line that intersects this line at right angles at this point? So, I need a line that has a specific gradient and it passes through this point. Now, let's hang on to this point for the time being. The gradient of a line that is perpendicular to another, right? If that's the case, when I multiply those two gradients together, I get -1. So if my first gradient is 2/3, right, as it is, and m1 is perpendicular to m2, that's what this little symbol means. That means that m2, right, we could say the product equals -1 and do some algebra, but frankly, I flip this upside down, find the reciprocal, and change the sign, so -3/2. So there we go, I've got the gradient now. The next thing I need is my y-intercept, and it just happens that we're lucky here that we're told it passes through the point 0,5, and as long as my first value is 0, that means that this is my y-intercept. So b equals 5. Putting those together, let's get out of the road here, then y equals -3/2x plus 5. Again, can we check this? Let's have a look. If we type them into Desmos, this is what these things are going to look like. Here is my original function here. Y equals 2/3x plus 5. That's my blue line. And here is my green line. Y equals -3/2x plus 5. Now, we can't tell that's definitely a right angle, but it looks about right. And they do intersect at 0,5. So that's pretty good. Okay, nice bit of confirmation there when you've got Desmos handy, or some graphing software. Now, this might be a little bit new. Okay, the general form of a straight line. We've dealt with general forms of equations a little bit before, perhaps with quadratics, where we have ax squared plus bx plus c. Okay, there are other forms we could express our quadratics, like when we complete the square, and they're good for different things. The general form of a straight line is a nice standard way of doing it, and we can use those coefficients in standard sorts of ways. Now the general form is ax plus by plus c equals 0. A, b, and c must be integers, that is whole numbers, and a must be positive. So we rearrange any equation until it meets those criteria. And here's an example. A line has a gradient of a third and a y-intercept of -2. That means that we could write in gradient intercept form very simply. Y equals 1/3 x minus 2. That's not what we're asked for. That is the equation of the line, but we want it in general form. We're going to begin by making all of these integers. Multiply everything by 3 and we get 3y equals x minus 6. Now we need to get all of the constants and variables, all of the terms, to the same side. So I'm going to subtract 3y from both sides. X has a positive coefficient of 1, the coefficient of y, and the constant. So a, b, and c are all integers, and a is a positive integer. So there we go. That is this equation here expressed in general form. Well, that's pretty much it for today. So we looked at the equation of a straight line, and in gradient intercept form, y equals mx plus b, the coefficient of x is the gradient and the constant is the y-intercept. However, I could also express this in general form. That's ax plus by plus c equals 0. A, b, and c are integers, that is whole numbers, and a is positive. Okay, that's it. If any of this is a bit hazy, if I've made a mistake somewhere, and certainly I could have, make sure that you jot that down so you don't forget, and ask me during class. Okay, thanks very much, Year 11. I will see you then. Bye.